So in this lesson, we're going to do trigonometric functions. So the three functions of trigonometry are your sine of x, cos of x, and the tangent of x. Okay, so the first step is to learn how to draw these three functions. So we're going to make use of 4 steps, the originals that we've always made use of, even with your cast Cartesian plane. So you know that we always start on 0, then we have your 90, 180, 270, and then to 360. So you will notice that with the x-axis that we make use of, it's 90, 180, 270, and 360 for all the three graphs. Okay, so next I'm going to show you how to create a table on your calculator. All right, in a Casio calculator, the first thing you're going to do is to go to a mode. So you will see that number 3 there is a table. That's what we want. We want a table form. So I will go and click on number 3, and then we get f at x. All right. So what I want now is to do the table for sine of x. So I will say sine, and then inside there we want an x, which is here on the button here, but that x goes with my alpha color. You'll see that alpha is in the same color as in the x behind them. So that means I'm required to go alpha and then that close bracket button, because there is an x just behind it there, and there I have an x. Remember to close that bracket. Okay, there we have it. And then I will say equal sign, equal, and then I get a g of x. You only do g of x if you want to have a second function in. So let's say the question says draw two functions in one set of system. But for this exercise, we're just going to do sine of x. We're not going to do the second function, so we will skip g at x. How do I skip g at x? I'm going to go to my equal sign again, say equal, and then it says start. Where do we want to start? Okay, we want to start from 0 to 360. So most of the times on your questions, you will be given the domain, which tells you where x should start and where it should end. So that's what you will then follow. So with us here, we're going to start from 0. So I will go and say from 0, and then equal sign. Where do we want to end? 360, equal sign. Perfect. What is the step? So our step is that the x-axis, that was the 0, 90, 180, 270, 360. So that means we've been adding 90 to get to the next number. 0 plus 90 is a 90, 90 plus 90 is 180, 180 plus 90 is 270, and 270 plus 90 is 360. So that means we've been stepping using 90 degrees. So that will be our step. Okay, so our step is going to be 90. So I will go and say 90, and then equal sign, and there you have your table. So on the table, you will see that 0 goes with a 0, 90 with a 1, 180 with a 0, 270 goes with -1, and 360 gives us a y of 0. So now, with the drawing of the sine of x, you go create your Cartesian plane. Normally, this is given on tests and your exams. You will be given the graph paper, and then there you would already be given your step. But if it's not given, use a ruler, do your x-axis, the lines, and then also the y-axis. Make sure that the spaces in between are equal. The space between 0 and 90, between 90 and 180, between 180 270, and between 270 and 360 are exactly equal, then the space between that 0 to 1 and 0 to -1 should also be equal on your y-axis. Very, very important, okay? So on that calculator, when x was 0, y was 0. So here it is. So it is this point here. And then when x was 90, y was 1. So we have x 90 and then y is 1 over there. So that is that point there. And when x was 180, y was 0. So it is a point over there. When x was 270, y was -1. So there we have 270 that goes with that -1. Then we have a point there. And then when x was 360, y was 0. There's a point there. Then with the drawing, you just follow your points, making sure that the maximum curves. So you're not going to have a point like this. It has to curve, okay? And then at 180, you curve again at 270 and -1, and then you stop there at 316. So this graph has a maximum at here at 90 degrees with 1, okay? And then its minimum is here at 270 degrees with -1. Then with a cos, if you apply the same steps on a calculator to get a table, you will get that 0 with an x of 0, then y is 1. So we have it here with an x of 90, y is 0. Then with an x of 180, y is -1. It's this point here. With an x of 270, y is 0 point there. And with an x of 360, y is +1. And it is that point there. Okay, so where is our minimum for this one? It's there, okay? The point that is at the lowest. So this is our minimum when x is 180 and y is -1. And the maximum will be here as well as here, the highest points, okay? So that is when x is 0 and then y is 1, and then here that is when x is 360 and y is 1. So this gives us the maximum, and then this is the minimum. Okay, with the tangent, let's go to the tangent, applying the same steps on your calculator to get the table. So the tangent would have given you that at 0, y is 0. There is that point over there. And then when x is 45, y is 1, it's that point over there. But when you get to x equals to 90, the calculator will then give you an error. So that means it's an asymptote. The graph does not exist at 90. And then you know with functions, just like with your hyperbola, if we get an error, it is an asymptote. So this is the asymptote. That is where the graph does not exist, and we indicate that with a dotted line. Okay, there we have our vertical asymptote, which is indicated by a dotted line on the 90-degree x-intercept, and then 135 gives us a y of -1. 180 gives us a y of 0. Okay, then we get that. So that means because we never reach 90, the y will forever be approaching that, or the tangent. And then again from 90, then we stop at 180. All right, so with these three graphs, you'll see that a full function of sine of x gives us an S shape, okay? And then it stops at 360. So that is the period of the graph. That's 360. And then with the cosine, the full graph gives us a C shape, and then it stops at 360. That means the period of the cosine graph originally is 360. With your tangent graph, we get half of the graph before 90 and the remaining half after 190, and it stops at 180. So that means the period of the tangent graph is at 180. So you need to have the three basic graphs in your head in order to be successful in answering some of the trigonometric functions. So, and which are really quite easy to remember or draw if you don't remember them. Okay, so what are the properties of trig functions that you need to know? First, it is the period that we just discussed. So a period is the length of interval that contains exactly one cycle. So that means the full graph. Just like we said that the full graph of a sine should make that S. Where that S stops, that's your period. With the cos, that is your C, and then with the graph, with the tangent, it's that half and a half. So where the second half stops, that's where it makes your period. So that means that full circle for sine stops at 360, a full circle for cos happens at 360, and a full circle at a tangent happens at 390. So the formula for your period, okay, will be, okay, we say period for your sine and cos will be 360. That's because originally a full circle happens at 360. Then you divide by k. This is for sine and cos. And then the period for the tangent is equals to 180 divided by k. Okay, that's because originally the tangent graph makes a full circle at 180. So for sine cos 360, for tangent 180. So this is for the tangent. What is this k? Okay, that is the coefficient of your angle. So if you have sine of x, the coefficient there is 1. So that means k is equals to 1. What if you have cos of 2x? The coefficient of the angle x is 2. So that means here k is 2. What if we have tangent of let's say 3x plus 2? So you'll see that the angle here is x plus 2 because it's inside a bracket. So that shouldn't matter. So what is the coefficient of that whole angle? It is 3 there. So that means in this case, k will be equals to 3. So you would have to make a substitution of the k in order to get the period if you get such functions. You also need to know the amplitude. So your amplitude is the maximum or the minimum minus the minimum value of your graph, right? Okay, so this is normally the coefficient of the entire graph. Okay, so in our the basics then, you'll see the coefficient of sine is 1, of cos it's 1, and then of tangent it's 1. So that means the amplitude is that 1 there. What if the graph is y equals to 4 cos of x? What is the coefficient of the entire function? It's 4. So that gives us the amplitude. The amplitude also goes with your range. So you know the range is the y-axis from down upwards. Okay, so the range of our tangent here, or let's say of this cos, you will see that the graph vertically starts from -1 to 1. That is your range. So that means your range, you will say y is between -1 and the 1, or you can make it a bracket -1 to 1, square bracket, less or equals to, because -1 and 1 are included. So just remember, if they say amplitude, your amplitude in this case will be 4. But what if we were asking for a range? Then we would say the range is y between -4 and 4. So you see how your amplitude and range relate. So amplitude strictly number 4, and the range is from the negative value to the positive value. Okay, unless if there is a vertical shift, of course. We will talk more about that later. You also need to, okay, the range I've already spoken about it, which if there isn't a vertical shift, then it's the same number as your amplitude. Okay, and then also, okay, mentioned all of them. So next we are going to discuss the vertical as well as your horizontal shift. Okay, now the vertical and the horizontal shift. Let's start with the vertical shift. Okay, so the vertical shift is a shifting of the graph up, so down or up. Okay, so the effect is this Q here. So if you have a function plus a number, so that is the Q units upwards. If you have a function minus a number, that will Q units downwards. So a plus is upwards, a minus is downwards. So with this graph here, we have a function that is true sine of x, because it's a function minus a number. So that means there's a vertical shift of -1. So that whole graph will then shift 1 unit down. All right. And then with a horizontal shift, okay, a horizontal shift, it's a movement of the graph either to the left-hand side or to the right-hand side. So we get a function like this one. So notice that the whole angle is x plus 30. So there's a difference with these graphs. When we have y is equals to sine of x plus 30, then we have y is equals to sine of x plus 30. Difference. You'll see that x plus 30 are both in a bracket. So that means that is the whole angle, right? And then if both of them are inside a bracket, that is a horizontal shift, like the one we have here. But if the x plus 30 were not inside a bracket, then that is a vertical shift. That would be 30 units up. But with this one, because x plus the 30 are both in a bracket, it's a horizontal shift, meaning 30 units to the left. Yes, that's correct. So with a horizontal shift, a plus indicates a movement to the left, and negative indicates a movement to the right. So it's unlike your vertical shift where negative is down and positive is up. So naturally you would think negative is left and positive is right. So just remember with your trig functions, positive means left and negative means right. So with y is equals to sine of x plus 30, that means the graph of sine of x will then shift 30 units to the left because it's a plus. Okay. Let's see how they ask trig functions in exams. Okay. So it's given that in the diagram, the f at x is tangent bx. It's drawn, and then it's between the interval -90 and 135. So it starts from -90, ends at 135. The first question is to determine the value of b. Where is b in this case? Okay, so it's tangent of bx. Our angle is x, and the coefficient of that angle is the b that they are looking for. We know that the relationship with the function and the coefficient of an angle is a period. So that's where we start. Perfect. What is a period of a tangent? We know that period of a tangent is 180 divided by k. So let's substitute what is our period in this case. Okay, so if you remember, the tangent graph is this first half and the second half. So if we have those two pieces where it ends, that is our full circle. So this tangent graph is making a full circle at 90. So that is our period. So our period is then 90, which is equals to 180 divided by our k is the coefficient of x, which is our angle, and that coefficient is b. Okay, and then this is what they are looking for. This is the same as over 1. So we're going to cross multiply. 90 times b, it's going to be 90b is equals to 1 times 180, that's 180. And if you divide both sides by 90, therefore b, if we divide by 90 by 90, our b will be equals to 180 divided by 90 is 2. You could have done that by way of observation if you didn't want to calculate. You would have checked, but originally the period of a tangent is at 180. But now our period is at 190 instead of 180. What would make 180? What would I have to divide 180 by in order to get that 90? And that is definitely a 2. Okay, so you could have just done an observation instead of a calculation. But if you feel more comfortable with the calculation, then go ahead with it. So the next question, it says, determine the values of x in the interval 0 to 135 for which f at x, the whole graph, is less or equals to -1. Where is this graph less than -1? Okay, let's go check. Okay, between 0 and 135, our graph is on the positives before 45, and then it's on the negative between 45 and 90. So whatever we are looking for is somewhere there. Okay, then we go check again. Where is our -1? There is -1. So that means we know that x will definitely be between 45 and some number. What would be that number? It's this number here. All the values just before -1. So what is the number between exactly in the middle of 45 and 90? So in your calculator, you can go say 45 plus 90 because we want a number in between. We added two numbers and then we divide that by 2. So that will give you 67.5. So the x will be between 45 degrees and 67.5 degrees. So this is the answer. That is that piece of the graph there that is less than -1. All the numbers down to 1 are less than -1, and the piece of a graph that is there is between -45 and 67.5. All right. So now graph of h is defined as, so h at x is going to be equals to tangent b x plus 55. Notice that the x and the 55 are both inside a bracket. We immediately know that is a horizontal shift. It's a horizontal shift. Okay. If both x and 55 were not inside a bracket, we would know that it's a vertical shift. So the question says, write down the equations of the asymptotes of h in the interval that is between minus 90 and 135. So the horizontal shift, we know our graph has shifted 55 units to the left, because that is a plus. So what we can do is get the original asymptotes. We need to get the original asymptotes and then shift them, because the question is asking for the asymptotes. So originally, our graph's asymptotes, the dotted line there, it's at minus 45. So x is equals to minus 45. And another asymptote, there's a dotted line, it's at 45. We have x is equals to 45. And then lastly, I think I just saw another asymptote. The other asymptote, there is a broken line. It's at 135. Let me just confirm where we're supposed to work. Yes, we're supposed to work between minus 90 and 135. So we include that asymptote. So we're going to shift all three 55 units to the left. 55 units to the left, because we had a plus 5 that is inside a bracket with the angle x. All right. So we've determined that originally the asymptotes at minus 45, at 45, and 135. Those are the broken lines at the graph. So if we shift this 55 units to the left, firstly, we're going to have minus 45 minus 55, which gives us minus, it's minus 45 minus a 55. This gives us minus 100. Minus 100. And then this one, 45 minus 55 is going to give us minus 10. And lastly, 135 minus 55 will give us 80. Remember, the answer was supposed to be between minus 90 and 135. So it cuts this one out because it's outside that bound. Therefore, our asymptotes after a vertical or a horizontal shift of 55 units to the left will then be x is equals to minus 10 and x is equals to 80. The next question says, in the diagram, the graph of g at x is equals to cos x plus 60. It's drawn from the interval minus 150 to 120. 150 to 120. So the question says, on the same set of x's, that means right here, we need to graph k at x being equals to minus sine of x. For the interval, same interval, we need to show all the intercepts with the x's as well as the coordinates of the turning points and endpoints of the graph. So on your calculator, you know you're going to go for mode and then choose option 3. So as soon as you get that, option 3 is table. As soon as you get that, then it's going to give you f at x. On the f at x on your calculator, you will then go sine you will say minus sign. It will give you an open bracket. You will say alpha x and then say equal sign. It's going to give you g at x after that, which we don't have. You just click equal sign to skip it. Then it's going to ask for the start. We are starting at minus 150. So your start will be 150. Then it will ask you for the end, which is 120. So that is given. We are given the interval. Let's check what is the step. This is stepping with 30. The step is 30. You will see that it's minus 30 minus 60, minus 90 minus 120 minus 150, and then 30 and so on. So our step, in this case, it's also given when we look at the graph that it's a 30. Great. So with our graph, your 1 minus 1, when x is 150, then your y is going to be a half. We're going to have a point over here. Let me see if I can use a different color. Okay, we are going to have a point over here. And then when x is equals to minus 120, then our y is going to be about 0.8. So we're going to have a point here just below 1. When x is equals to minus, let's have minus 120 here. When it's equals to minus 90, because they said we should show all intercepts. So that means we need to fill up those x-intercepts as well. All right. And then here, when x is equals to minus 90 on the table, then it's equals to 1. There we have it, minus 90 with a 1. When our x is equals to 60, the y is also about 0.8. So it's going to be the same point here. And then when y is equals to 30, when x is equals to minus 30, our y is a half. When x is equals to 0, our y is a 0. When x is equals to 30, y is minus half. And then when x is equals to 60, our y is about minus 0.9 or 0.8. And then when x is equals to 90, our y is minus 1. And when x is equals to 120, our y is minus 0.8 or 0.9 when we round it up. So we're just going to follow those dots. There. 10 there. Perfect. So our maximum is clearly here at minus 90 and 1, and our minimum is down there at, okay, we have 60 and 90 there. We need to fill it up because they said we should show everything. So this will be at 90 and minus 1 for 4 marks. That was simple. You just need to know how to use the table mode on your calculator. And then next, the question says we should determine the minimum value when cos of x plus 60 minus 3. Okay, where is that cos? So our graph originally is cos of x plus 60, but now they just added minus 3 to it. So it's the whole angle, which is the bracket. So the whole function minus a 3 that is definitely a vertical shift. So that means there is a vertical shift of 3 units down because it's a negative. Let's check. Originally, our minimum is this one here. What will then be a minimum after we shift these 3 units down? So it's going to be x will remain the same because we are shifting y here, and then y will move from -1. -1 minus 3 will then be -4. So if this shifts downwards, then this minimum is going to sit at -4. Okay, that will be the new minimum value. The new minimum value will be equals to, it will be y is equals to -4. All right. And then solve the equation. We have to solve that equation for that interval. So it's set solve. So we're not using the graph. We're going to make use of how the knowledge that we've learned as to how to solve the general solution of trigonometry. All right. So we can take that sign to the right hand side. We will then have, let me just write it here. We're going to have cos of x plus 60. Taking that sign to the right hand side will be equals to minus sine of x. All right. And then since now we have two angles, two functions, two different angles, we've learned when we were solving for the general solution that you're going to have to change the other one to a co-function. So I'm going to change the sign there. Okay, what will we have? We are going to have cos of x plus 60 equals to, then we can change that and make it a cos of 90 plus x. We're going to go with its negative because in the 90 plus x sign is positive. So we continue with that negative. And then we've learned then that we can drop the coses and just continue with the angles. So our angle on the left hand side is x plus 60. Our angle on the right hand side is minus 90 plus x. And then if we take that, it's going to be, let's break the bracket. It will be minus 90 minus x. This is just basic algebra now. X, that side is going to be x plus x, which is 2x, which is equals to 90 minus 90 minus 60 will then be minus 150. All right. And then what we then do, divide both sides by 2. Therefore, okay, we are at 150 before. We need to make it general. So I'm just going to plus 360k, and then if we divide everywhere by 2, so always make sure that when you do a division, it's after you've added the generalization. Just always remember that you take the angle as it is before you remove it with any number that's with the angle. You would have to generalize first. All right, so dividing everywhere by 2, that means we're going to have x is equals to minus 75, 150 divided by 375, and then we will have plus 360 divided by 2, that is 180k. Okay, and then now we can just play around with the k since it's an element of all real numbers. So the real numbers would be 1 to infinity. So we can just check. So we have minus 75. So if our k is 0, so the real number starts with a 0, sorry. It's going to make this as 0. Then we have minus 75, or x is equals to, if k is 1, then we're going to have minus 180 times 1, which is 180. 180 minus this 75 is going to give us 105. If k is true, then we get 360 minus 75, which is 285. So we can't go beyond there because our interval says we should stop at 120. So as soon as the answer is more than 120, then we stop. So we have x is equals to minus 75 or x is equals to 105. All right. So the next question says, determine the values of x for the interval minus 150 to 120 for which f at x plus sine of x is greater than 0. All right. Determine the values of x for which that is greater than 0. So I think we can just shift that to the right hand side again and then get ourselves that cos of x plus 60 is greater than minus sine of x. If you remember, the original graph was g at x, which is cos of x plus 60, and the graph that we drew was our kind of, what was it called? It was called it's k at x, which is minus sine of x, k at x. So what we want is to determine which x values will give us g at x greater than k at x. So on the graph, we can look for the parts where g at x is on top of k at x. That's how we know that it's greater. So when we look at this, k at x is on top of g at x. So that part is not taken because k at x here is greater than g at x. When the graph is on top of the other, that means it's greater than it. Then from this value up to here, we then see that g at x is on top. That means that is the part where g at x is greater than k at x. That's what we are looking for. Okay, so if you look at it, it's the number after 60 and before 90. And then if you look at the number right in the middle of 60 and 90, it's going to give us 75. So I will guess that the graph, this part here, is between 75 minus 75 and then this part here looks like a 105, just after 90 before 120, 105, and then that gives it away also the answer that we found here, that the number, that number that is happening, that's where they meet also the intercepts. Remember, we did find that it was minus 75 and 105, so there was no need to guess after all. So that would be the interval. Between those intervals, it happens that g at x is on top of k at x. That means that's where g at x is greater than k at x. Lastly, the function g can also be defined as y is equals to minus sine of x minus a theta, where theta is an acute angle. We need to determine the value of theta. All right, so let's try to get that form of a graph. I think we can start with y is equals to cos of x plus 60, because they did mention that the function g can also. So that's why we start with function of g, which is cos of x plus 30. We're going to try to get to a sine using this graph. We start with a g and we try to get to a sine. Perfect. How would we make this a minus sign? All right. The cofunction of a cos would be sine. Okay, it's going to be sine, and then it will be 90 in 90 minus our angle there is x plus a 60. Okay, so we know sine 90 minus will be a cos. Okay, so what are we then going to have? We will have sine of 90 minus 60. It's going to give us 30, and then we have minus x. All right, but we want an angle minus plus something. So that means here we have the same thing as minus x plus a 30. So I'm just going to make it a negative angle minus x minus 30. And then we know the negative angle of a sine is a negative sign. So this then becomes minus sine x minus 30. So if you look at it there, we have the same thing that then makes our theta equals to 30 degrees. All right, this question here says in the diagram, the graphs of f at x, so this is f and g at x, which is sine x plus b, are drawn for the interval minus 180 to 90. So they are the graphs. So the first question is to write down the value of b. There's b, there go with the sine graph, which is g. So it's this graph here. This is the kind of a question where you need to know the original graph. So the original sine graph is like this: 0, 90, 180, 270, and 360. So you will see that originally the sine graph passes at 0. So this sine graph should have been passing here at 0 originally, but instead it's passing at minus 30. So that means there was a horizontal shift of minus 30, of 30 units to the left. And we know that negative to the left means plus. So that means b here is positive 30. And then what is the period of g? There is g. The period, what is the coefficient of our angle? It's just 1. So that means nothing changed. Originally, the graph of g is 360. It will remain 360 because k, the value of k is 1. So 360 divided by 1 will be 360. All right. So now we need to write down the values of x in the interval 180 to 90, for which f at x minus g at x is equals to 0. So that means where f at x is equals to g at x, if we take g to the right hand side, where are the two graphs equal? That is the point of intersection. Point of intersection. So we're just going to check where the two graphs meet. Okay, they meet here, they also intersect here. So that means the answer is x is equals to minus 150 and x is equals to, they also intersect at 30. All right. And then 6.4, for which values of x in the interval 180 to 90 is sine of 90 minus x greater than g at x. Okay, sine 90 minus changes that to a cos. So this is cos of x greater than g at x. And according to our information, cos of x is f at x. So we need to go check where is f at x greater than g at x. So that means in our graph, we're going to check which region of the graph is f at x on top of g at x. Okay, let's go check. Before 150, g is on top of f at x. but between 150 and 30, f is indeed on top of the g. So this is where f is greater than g. So this is when x is between minus 150 and 30. All right, and we can use the brackets. If you don't want to use this, you can just say x is an element of minus 150 to 30. Just depends whether you want to use the bracket or this interval. All right, and then the last question for that one, the graph of h is obtained by shifting f 3 units upwards. Determine the range of h. So let's check first what was original f. We need to shift f 3 units up. What was the range of the original f? Okay, the range of the original f was between -1 and +1. Okay, the range originally was between -1 and +1. So if we shift this 3 units upwards, that means we have to add 1 to the original range. -1 plus 3 is -2, and then 1 plus 3 will then give us a 4. So the new range is -2 or 4, or you could have just said y is an element of sorry about that, it's a y element if we use the brackets, or you can just say y is between 4 and minus, no, it's 2, it's not -2, sorry, -1 plus 3 gives us +2. So this is +2. The mind is now tired. -1 plus 3 is a 2. So you always, sometimes you just need to start with the original. So with a question like this, which I'm not going to show, it's very easy. So consider the function f at x and g at x. Write down the period of g. We're going to check again, does an angle have a coefficient? Yes, it has a coefficient, which is a 2. Since it's a cos, we know that period is 360 divided by k, and our k in this case is a 2. So that's 360 divided by 2. That means our period is 118. The range of f, here is our f with coefficient of 1. That graph has a coefficient of 1. So that means the range will be between -1 and 1. If they had asked for an amplitude, our amplitude would just be equals to 1. And then on the same grid provided in the answer book, draw the graph of f and g between -90 and 118. So the first thing that you're going to check is in your answer book, what was the step? Okay, the step is a 13. So on the answer book, the step is given to be a 13. So on your calculator, again, mode number 3, which is a table, it will give you f at x. Then you're going to put in sine x minus 30. So don't make the mistake of separating the x with the 30. You will not say sine of x, close it and say minus 30. Remember, that's a vertical shift. Please just keep it both in the bracket just as you see it, minus 30. Okay, and then when it says g at x, you're not going to click equal sign like we've been doing. That's because we didn't have g at x, but in this case there is a g at x. Then you will put in cos of 2x for your g at x. When it says start, you will say minus 90. When it says end, you will say 180. When it says step, you're going to say 30. You will then get your table that will be x values, and then it will give you f at x and g at x. Then it's going to give you those values from 0 30, 60. No, we have to start at minus 90. It will start at minus 90, then minus 60, minus 30, 0, 30, and so on. So you're going to draw the first graph, join the point, the dots, and then please use a different color so long as it's not red or green. And then also join the points of your G at F graph. And then the marks are 5. So that is quite an easy thing. Then when you're done for the last 3 marks, you will then write down the coordinates of the points of intersection. You're just going to check where the two graphs intersect, just like we had here, where they meet, they intersect. So that will be an easy one. Okay, let's look at this one here. We're given f at x is cos x plus q, g at x is 2 sine b x. Okay, between minus 60 and 120. First question, you need to find the coordinates of the maximum turning points of g. There's the turning point. So the coordinate x is 30 and y is 2. And then the minimums are here. Okay, that was easy. And then determine the values of x where f is strictly increasing, okay, in the given interval. F. So f is increasing here, it stops and it starts decreasing. So it's definitely increasing between minus 60 and 0. Yes, we use a round bracket because at minus 60 it's a 0, and then at 0 it's stationary, it's at maximum, so we don't include them. Or you can just say x, that's when x is between minus 60 and 0. Don't use less or equals to because we need to exclude the endpoints. All right. And then the next question, we need to determine the values of q and b. So next we're supposed to determine the values of q and b. Okay, let's go. So let's start with a b because at least we know that the relationship between the coefficient of the angle is the period of a function. So the period of a sine graph will always be 360 over k. And then let's check, do we have a full circle? Yes, the full circle of this sine graphs, it happened, and it happened at 120. So that means the period is 120, which is 360. Our k is that b that we are looking for. With cross multiplication, therefore b will be equals to 360 divided by 120, which is equals to 3. And then what about the q? It's a vertical shift. So something happened to the cos graph. Originally, cos graph, if you remember, it's at maximum at 1. Né? So this one is at maximum at a half. So that means this graph, which was originally at 1, shifted half units downwards. Okay, and then downwards is a negative. That means q is equals to minus a half. We went half unit downwards. Downwards is represented by thus minus. All right, and then use the graph to determine. Use the graph. It doesn't say solve, it says we need to use the graph. We need to determine that 2 cos x sine 3x minus sine 3x is greater or equals to 0. So we immediately notice that there's a common factor. So I'm going to take out that common factor 3x. And what I'm trying to do is get our graphs there. So our graphs is cos x minus a half. Okay, let me just write them down. Our graphs is cos x minus a half. Okay, and then 2 sine 3x. Also 2 sine of 3x. We have 2 sine 3x, but we do not have minus a half. So if I take minus 3x out as a common factor, this is going to give us 2 cos of x minus 1 greater or equals to 0. We want this to be minus a half, and we want these 2 here. So what I'm going to do is take out these 2 out as a common factor. So if I take the 2 out as a common factor, we will have 2 sine of 3x, already have that. Inside the bracket, 2 cos x divided by 2 is cos x. 1 divided by 2 is a half, greater or equals to 0. So we have those 2 graphs. Okay, 2 sine 3x is g at x. So it means we have g at x times by f at x, which is cos x minus the half, greater or equals to 0. We know that this is multiplication, so we want the graphs. When we multiply the values of the both graphs, we'll get a positive value. We know in mathematics, greater than 0 means positive, and this means multiplication. So let's go check the graph now. We need to use the graph. Okay, our graph of f at x between minus 60 and this value here, what's the story there? F at x is on the positives and g at x is on the negatives. We know positive times negative is a negative, so that part doesn't apply. And between here and here, what do we have? G is on the positives, F is on the positive. Then positive times positive is a positive. This region is in. And then also, what happens between the last one, between here and here, both graphs are on the negative values, and negative times a negative is a positive. So that means the 2 graphs, if they are multiplied, they will be positive between this value and that value. That is between 0 and 120. Perfect. Okay. Because between 0, we start having both of them positive. Just have a look at that. I'm just going to rub the vision. Okay. You will see that between just starting up until 0, we have positives and negatives, which is a negative. But at 0, positive with a positive, positive, positive with a positive, positive, negative times negative is negative. So that's why we're saying the product of the 2 graphs are positive between 0 and 120. Okay, that will be the same question here. So with the others, you know how to find the range and the period by now. You would know how to draw that graph between minus 180 and 180 by using the table method on your calculator. And then once they are drawn, again, you're going to check what will be the product of the 2 graphs. Where will it be? Positives. So if the one graph is on the positives and the other is on the negatives, then you know that positive times negative is a negative, then that wouldn't apply. But if both of them are on the positives, then that's a positive times a positive, which is a positive. If both of them happen to be on the negative, that would be a negative times a negative will be the positive, then that will be in. Let's look at, let's see if we have another question. Okay, so it's a common question. So here you're given the tangent and the cos. You need to sketch both of them on the same set of axes for 5 marks again. That would be easy, using start of minus 90 with an end of 180, and check the step. It might be 30, 45 or so on. And then you will see that question again. When will the product of the two graphs be positive? Because greater than 0 is a positive. So it's quite a common question. And there is a question again. But now, when will the product of the two graphs be negative? Because we have a less than 0. And then here you're going to find where in that region is the graph of f on top of g at x. And then here, where is the graph of g at x on the positives? Remember, these are the negatives and that are the positive. So with a graph like this graph is on the positive here and it's on the negative here and there.